everyone. Hello, we have started this 1 p.m. live. Okay. Am I visible? Am I audible, everyone? Can you let me know in the live chat? Just let me know in the live chat if I'm audible and if I'm visible. Where? Hi, Radhe Radhe. Hi, Amit. Hi, everyone. Hello. Today at 1 p.m. we have a live scheduled for pre-board physics exam. Wait. Let me. Did I just open? Yeah. Hi everyone. So today in this live we'll be seeing the most repeated top 20 most repeated questions, previous year questions. So that will be helpful for your pre-boards for class 10th, of course. We'll be seeing mostly in this live we'll be seeing from the chapters electricity and magnetic effects of electric current. So are you guys excited? Hi everyone, we'll just start in 1 or 2 minutes, guys. Let everyone join. We will I want you to share this link with your friends, with your cousins who are preparing for boards as well. Hello Abhimanyu. Welcome everyone in the live session. We will be doing 20 most important, most repeated previous year questions to prepare for your pre-boards as well as for your boards. Hi everyone. Hello. Am I audible and visible properly? Okay, can we start the live session? Can we move on to the first question of today's live? Thumbs up. Can I have thumbs up from you guys? Okay. Yeah. Okay, let's start our first question. First question, read it carefully. Now you will read it once, then I'll read it, then we'll solve the question. I want you guys to keep a pen and paper with you so that you can solve the questions, because the chapter electricity is majorly, it comes from electricity, majorly numericals come. Okay, let's read the question. Read the question carefully, very calmly. The resistance of a resistor R, there is a resistor R and its resistance is reduced to half of its initial value. Let's say the initial value is R. Now its value is reduced to half of its initial value. Correct? If other parameters of the circuit remains unchanged, if all other parameters of the circuit remains unchanged, then we have to see what will be the amount of heat produced in the resistor. The amount of heat that will be produced in the resistor if its resistance becomes half but all other parameters remains unchanged. Okay, Amit is saying C. Anyone else who wants to answer this question? Amit is saying C, half. This question has come in CBSE 2023 boards. So these concepts are very important. Okay. Anyone else? Okay. Let's see the answer. For heat, we know we have a formula which is H equals to I square R T. Correct? Now all other parameters are same. Then what changes? The R. If my initial heat is Ri, so Hi is simply I square R T. Correct? If now my final heat where the resistance becomes half, so here it will be Ri by 2 into T. Ri is simply just R. R by 2 into T. So H final. Now if I just rearrange it, can I write I square RT divided by 2, and I square RT is nothing but H initial, so it will just be half of the initial value. Correct? So Amit was correct. 2 times, no half. It will be half, right? I square RT is our formula. If my R becomes R by 2, so heat will also become R by initial value divided by 2. Correct? The amount of heat produced in the resistor will become half of the initial heat that was being produced in the resistor. Correct? Understood? Can we move on to the next question? Everyone? I guess my net is slow. Okay, let's move on to the next question. Okay, read it carefully and calmly. Second question, read it carefully. A wire of length L, a wire of length L is gradually stretched so that its length increases to 4L. First, the length was L, then the length became 4L. If its original resistance is R, if original resistance is R, then its new resistance will become, we have to find R2. Correct? You have pen and paper with you, right? Solve this question. Let me know what will be the answer. Okay, let me know the answer to this question. If I have a wire and I stretch it and its length becomes 4 times the original length, then how will its resistance change? Amit is saying C. Again, C. Okay. Saying C, 16R. Is he correct or not? 4R, Trev is saying. Anyone else who wants to answer this question? I want you guys to take care and answer this question carefully. Trev is saying 4R, Trev is saying 4R, and Amit is saying 16R. Let's see who's correct. Okay, let's move on to the question. Now, how we approach the question? We need to find resistance. So, formula of resistance, of course, rho L by A. Now, the one thing you need to take care in this question, that length became 4L. But if I stretch the wire, if its length is increasing, then its area of cross section will also decrease. Correct? The length will not come out of nowhere, right? So, the area becomes A by 4 as well. How much the length is increasing, the same amount will my area will be decreasing. So, this will be L2 and this will be A2, L1, A1. So, in the formula of resistance, rho L2 divided by A2, so this will be rho 4 into L1 divided by A1 divided by 4. Correct? Understood? And hence R2 will be 16 times rho into L1 divided by A1. Now rho into L1 by A1 is what? It's my original resistance. You can write L1, A1. If you write with subscripts L1, A1, L2, A2, it will be a lot easier for you guys to solve. Okay? So R2 will be 16 times R1. Correct? And if R1 is simply R, so that will be 16R. Amit was correct. Yes, you are right. It's fine, Trev. Okay, Abhimanyu said 16R, Amit also said 16R. Very good. Correct. Okay, moving on to the next question. The third question says a plastic insulation. Okay, read it carefully. A plastic insulation surrounds a wire having a diameter D and length L. So I have a wire. If you draw it, you can also imagine it. You let your brain imagine it. So it becomes even more clear, the concept. So this is my plastic insulation and this is my wire. The wire's diameter is what? It's D and length is L, correct? Now what they're asking, a decrease in resistance of the wire. Resistance is decreasing. A decrease in resistance of the wire would be produced by an increase in the length of wire, diameter of wire, temperature of wire or thickness of wire. They are saying that my resistance is decreasing. If my resistance is decreasing, what parameter will be increasing? It was length or diameter or temperature or thickness of the insulation. Thickness of insulation. This thickness. B. Amit is saying B. Abhimanyu is saying diameter of the wire. Okay. Anyone else who wants to answer this question? Anyone else who wants to answer this question? What will be increasing if the resistance of this wire is decreasing? Anyone? Okay. Let's see the answer. It is correct. The diameter should be decreasing. Why? Because the value of resistance is rho L by A. So area of cross section is pi r square and r can be written as pi diameter by 2 into square. So technically the area should increase so that my resistance will decrease. Correct? So for area to increase, the diameter of wire should increase. Correct? This question also came in 2023 sample paper. Okay. Let's see next question, which is fourth one. Read it carefully again. This requires a little bit of calculation, so read it carefully. Four wires of equal length. Write it down. 4 wires and they are of equal length. Correct? Now, and of resistance, their resistance is 15 ohms. Now they are forming a square. These 4 wires which are of equal length, they are forming a square and each has a resistance of 15 ohm. The equivalent resistance between two opposite ends of the square will be. Can you draw this diagram first? Can you draw this diagram first, guys? Do you understand the question or not? Let me know in the chat. Do you understand the question or not? Amit gave the answer as 15 ohm. Okay. Okay. Let's draw the diagram. We have 4 wires of equal length forming a square. Each has a resistance of 15 ohm. This is also 15 ohm, 15 ohm and 15 ohm. What they are asking is the equivalent resistance between two opposite ends of the square. So between this end and this end, we need to see the, if we attach a battery, we need to see the resistance between these two ends. Okay. So if I redraw the diagram, if I redraw the diagram, can I make it something like this? If this is, let's say, my circuit, can I make it something like this? Correct? I did it wrong. Okay. We have 4 wires. So can I make it something like this? Okay. This is also the same circuit and these are 4 wires forming a square. We just rotated it. Now, if these are resistances here, so these two are in series, correct? Let's name it A, B, C and D. So A and B are in series, correct? And C and D are also in series. But these two with each other, they are what? They are parallel. Correct? Correct? So the equivalent resistance of AB will be 15 plus 15, that will be 30, and for CD as well it will be 30 ohm. Correct? And then these two are in parallel. So for finding equivalent resistance, I'll just add these with a parallel formula. Okay, so this is 1 by 30 plus 1 by 30, which will be 2 by 30, and it will be 1 by 15. 1 by R equivalent is 1 by 15, so R equivalent will come out to be 15 ohm. Correct? This is your answer. Understood, everyone? 15 ohm, 15 ohm. How are you? Who are you asking to? Okay. Let's move on to the next question. Okay. The fifth question says an electric iron, again read it carefully, an electric iron of 1500 watt, electric iron of 1500 watt and 1500 watt and 200 volt and a flashlight of what, 500 watt and again 200 volt are used in homes. They are being used in homes. Okay, the rating of fuse to be used should be, the rating of fuse that should be used should be what? Should be 10 ampere, 5 ampere, 15 ampere or 20 ampere. Who wants to answer this question? Who will answer this question? The rating of fuse. Amit is saying 15 ampere. Okay. Everyone else? What will be the rating of fuse? C, 15 ampere. Okay. Anyone else who wants to answer this question? What will be the rating of fuse? Fuse, rating of fuse. Okay, let's see what you can do. You can do this in two methods. Either you can add the power and divide it with voltage. Let's say the power, the formula of power is V into I. So either you can do for iron, which will be 1500. 1500 is power. Okay. This is iron. The power of iron is 1500 and voltage is 200 volt into I. So I, current of iron will be 7.5 ampere. Correct? And then when I'm doing for flashlight, again the voltage for flashlight into I. So this will be 500. Voltage is same. Why voltage is same? Because these are used in homes, and we know in homes all the appliances are used in parallel connection, and in parallel voltage does not divide. So by doing this, this will be 2.5 ampere. Correct? So you can just add these two currents. This will be flashlight and this will be iron, and the total current then will be the current from iron and flashlight, which is 7.5 plus 2.5, which is 10 ampere. The total current is 10 ampere. Now, the total current the iron and fuse are using is 10 ampere. And my fuse should almost be equal or a little bit greater than the required value of current. So the answer will be 10 ampere, because if it's 15 ampere and my iron can get damaged by 13 ampere because it's just using 10 ampere, 7.5 ampere. So if it can get damaged by 13 or 14 ampere as well, so the fuse value should be little bit greater than your required value. Yes, Abhimanyu was correct. So the correct option is 10 ampere. Okay, understood? Let's move on to the next question, which says, okay, read it carefully. Read the question carefully. The question says, a household uses the following electrical appliances. First, it uses a refrigerator. it uses a refrigerator of rating 400 watt. So this is power. Okay, then for 10 hours, time is 10 hours, correct? Then we have 2 fans, so their power is also given 80 watt, 80 watt each. So one fan is using 80 watt power and is using for 6 hours, correct? And then third, we have 6 tubes. So they are consuming power as 18 watt for 6 hours daily, correct? Now we wrote everything that was given in the question. Amit is saying no ma'am, 15 ampere. Why 15 ampere? Your current is 10 ampere, so the value shouldn't be greater, much greater than 10 ampere, okay? It will be 10 ampere. Okay, calculate the electricity bill for the household for month of June if cost of electrical energy is 5 per unit. Now keep in mind this, the month they are given. For June, do we have 30 days or 31 days? So we will have to divide, multiply accordingly, correct? So can you give me answer to this question? It's a little bit tricky, it needs a bit of a calculation, but can you solve it? Can you solve this question and give me the answer? We are given power and time for which they are running of each of these appliances, and we need to calculate the electricity bill. Can you solve it? Anyone with the answer? 841 rupees, Abhimanyu is saying. Okay, let's calculate it. Let's calculate. So, to calculate the electricity bill, we need to calculate how much electrical energy we are using. And the formula for electrical energy is power into time. Power is given, time is given. So, we can just multiply this. Electrical energy of refrigerator will be 400 into 10, and that will be what? 4,000 watt hour. If you can write it in kilowatt hour, because we use this in kilowatt hour, so this will be 4 kilowatt hour, correct? Electrical energy for refrigerator will be 4 kilowatt hour. Then for electrical energy of what? Fans, this will be again power into time, which will be 80 into 6, correct? 80 into 6 will be 480 watt hour, correct? So total electrical energy in kilowatt hours will be what? 0.48 kilowatt hour, correct? Can you tell me why do you need, why are we changing the units from watt to kilowatt hour? Can you tell me why we are calculating in kilowatt hours instead of just watt hours? 18 into 6. So this will be 108 watt hour. So power will be 0.108 kilowatt hour. Can you tell me why we are converting it into kilowatt hours? Somebody just deleted a chat. What happened, Amit? Okay, all this is correct. Power, this will be electrical energy of tubes, correct? Now one more thing we have to do. Let's write it first. ER is what? 4 kilowatt hour. 4 kilowatt hour. Electrical energy of fan is electrical energy. What happened? electrical energy of fan is 0.48 kilowatt hours. What is happening? Yeah, 0.48 kilowatt hours, and then electrical energy of tubes was 0.108 kilowatt hours. Correct? This is true. But these two energies are for one fan and one tube. Can you see? 80 watt each and 18 watt each. But we have 6 electric tubes and 2 electric fans. So we have to multiply this with 2 into 0.48, and then we have to multiply this with 6. Correct? Into 6, because we have 6 tubes and 2 fans. Correct? Hello Pooja. Because electricity units are calculated that way. Yes, you can say that electricity units are calculated that way, but we have, okay, I'll tell you the answer to this question after solving this. Okay? 0.48 kilowatt hour. Now this is the total energy these 3 appliances are using in one single day. In one single day. It's for 10 hours, for 6 hours, for 6 hours, one single day. But we need it for the month of June. Correct? We need it for the month of June. Is that correct? So how many days are in June? We have 30 days in June. So the total energy they are consuming in a single day, the total energy they are consuming in one single day. So that will be the addition of all these 4 plus 0.96 plus 648. Correct? This will be the total energy all of these appliances will be using in one single day. Is that correct? Okay. Now just add these and we'll have the total energy. It will be 4 and no, I did something wrong, right? So 4, 0.96 and 0.648. So it will be 8, 6.4, 4.608. Okay? You guys also do the calculation carefully. So this will be my total energy consumed in one single day. Now I can just multiply this with 30. For 30 days, the energy used will be 30 into 4.608, which will then be 4081 and 13.804 what? Rupees. No. Not rupees. This will be the total energy that will be using in one single month. Correct? For 30 days, we will be using this total energy in one single month. Now, the kilowatt hour, the conventional unit we have is 1 kilowatt hour is actually equal to 1 unit. Correct? So, for 1 unit, the price of 1 unit we are given rupees 5. So, 13.804 into 5 will be the total cost of energy used in 1 month of June. Correct? Is that correct? So can you just calculate this? You can multiply 13.804 with 5. Correct? Okay. Let's move to the next question. It was a bit, lengthy. Okay. Seventh question, read it carefully. Seventh question says, 4 identical resistors, each of resistance 8 ohm, are first connected in series. First they are connected in series, then they are connected in parallel. Okay, for series their resulting resistance is Rs, for parallel their resulting resistance is Rp. With resulting resistance Rp, find the ratio of, we need to find the ratio of Rs divided by Rp. Can you guys find this? The ratio of Rs divided by Rp. The ratio of Rs divided by Rp. 16 ohm. Amit is saying 16 ohm. Anyone else? Another answer if someone has. We have 4 resistors, we connected them in series and then in parallel, and they are asking us to find the ratio of Rs divided by Rp. Okay, let's solve this. For Rs, we know all the resistors will just add up. So 8 plus 8 plus 8 plus 8, and you should not be writing like this. You should simply be writing N into resistance of one resistance, which is 4 into 8, that will be 32. So Rs is 32. Correct? Then for Rp, we will find, how will we find? We'll use the formula like this, N divided by R. So N is 4 resistors, R is 8, so this will be 1 by 2, 1 by Rp. So my Rp is what? It is 2 ohm. Correct? Rs is 32 ohm, Rp is 2 ohm. So if I can just, if I need to find Rs divided by Rp, Rs is 32 divided by 2, this will be 16 ohm. 16 ohm is the correct answer. Amit was correct. Done? Understood everyone? Understood this question? This is also a very repeated question. These kind of questions have come in boards multiple times. Okay? Let's move on to the next question, which says, find the current through the given circuit. Find the current through the given circuit and then find the power across 2 ohm resistor. We need to find the current and then the power across 2 ohm resistor. Correct? Can you solve this question? Yeah, Amit is, by this emoji I can say Amit is slaying all the answers, all the questions. Can you solve this question? Find the current flowing through the given circuit and then find the power across 2 ohm resistor. मैम जैक JAC बोर्ड में आएगा. What is JAC? Can you solve this question? Let me know the answer, the total current you need to find in this circuit, and then you need to find the power only across 2 ohm resistor. Okay, Amit is saying 0.125 watt. Anyone else? 0.125 watt is what? Is power. Okay, and the current? Okay, let's see. So the first step, step 1, which I have told you multiple times that you have to see when you get some combination of resistors, is you need to calculate equivalent resistance. Correct? So first we'll calculate the equivalent resistance of this particular circuit. Let's name this 1 A, B, C and D. So RA is 1 ohm, RB and RC is 2 ohm, then RD is 6 ohm. So RB and RC are in parallel. RB and RC are in parallel. So their equivalent resistance will be what? 1 by RB plus 1 by RC, which will be 1 by 2 plus 1 by 2, which will be 1. So RBC, this whole circuit will have 1 ohm resistance. So can I redraw this diagram and something like this? Something like this. This is 4 volt and this was 1, 1 and 6. So 1, 1, 1, 1 and 6. Correct? This is my equivalent circuit now. Now all these are in series. So I can just add them. 1 plus 1 plus 6, which will be 8 ohm. So the resistance or the circuit can now be just made into this particular small circuit. This is 8 ohm and this is 4 volt. Correct? Done. Now we need to find the current. So we can just use Ohm's law and can find the current. Resistance is 8 ohm, voltage is 4 volt. So current will be 1 by 2, which will be 0.5 ampere. Correct? So my current through the whole circuit, current in the whole circuit will be 0.5 ampere. Yeah, so these questions are for CBSE boards, but these questions are from the concepts only. So you can revise this. If you are revising, you will eventually solve the questions that are coming in your state boards as well. Okay, so the value of current is correct, 0.5 ampere. Then we need to find the power in just this 2 ohm resistor or maybe this 2 ohm resistor. So we either need to find current in this 2 ohm resistor or the voltage in this whole circuit, because this is series and voltage divide in series, or we need current but this is parallel, so voltage current divides in parallel. So whatever formula you want to use, either I square R or V square by R, you have to calculate voltage or current through these 2 ohm resistors. Correct? Now the current we found out was what? 0.5 ampere. So these resistances are same. Let's calculate the current in this particular resistors if we want. 0.5 is coming here. Okay, and since these 2 resistors are same, this is 2, this is also 2, so equal amount of current will travel into these 2 paths. Correct? So 0.5 divided by 2, that will be 0.25. Correct? So the current through 2 ohm resistor will be 0.25. So you can just write 0.25 whole square into the resistance is 2. So this will be 0.0625 into 4 and the answer will be 2425. Okay? Correct. So the power through 2 ohm resistance will be 0.25 watt. Okay? Yeah, even if you are not from CBSE, these questions are based on very common concepts and these questions are repeated. So it will cover all your concepts. Okay? Okay? Can we move to the next question, everyone? Okay. 9th question. Read it carefully. Read it carefully. An electric motor rated 1100 watt. Electric motor rated 1100 watt is connected to 2 220 volt mains. 220 volt mains. We need to find the current drawn from the mains. First part. Let's calculate the first part first. Can you give me the answer to the first part? What will be the current drawn from the mains? I'm waiting for your answer. What will be the current drawn from the mains if power and voltage is given? Can you guys answer me this question? Anyone? Okay, let's solve this question. The question is given. Now we know the formula of power will be V into I. It's very simple. This is 1100, voltage is 220 and current. So current will be just 1100 divided by 220, which will just be 5 ampere. So my current will be simply 5 ampere. Correct? Everyone else is it can come in JEC board as well, Gavandhar Yadav. Okay, understood this part. Let's move on to the second part, which says electrical energy consumed if the motor is used for 5 hours daily for 6 days. I is 5 ampere. Amit is saying correct. The second part, we need to calculate electrical energy. We just saw from the previous question that electrical energy formula is power into time. Power is given, which is 1100 watt, into time is 5 hours but for 6 days. So that will be 5 hours for 6 days. That will be 30 hours. Correct? So we can just multiply by 30 and we will have 33,000 watt hour electrical energy, and we know we need to convert it into kilowatt hour. So this will be 33 kilowatt hour. Correct? The electrical energy comes out to be 33 kilowatt hour. Correct? Let's move on to the third part. The third part asks total cost of energy consumed if the rate of 1 unit is 5. So we have 33 kilowatt hour, correct, which is equals to 33 units, correct, and rate of 1 unit is what? 5 rupees. And for 33 units, the rate will be what? 5 into 33, correct, which will be 165 rupees. Correct? Can we move to the next question? Amit is correct. All the answers of Amit are correct. Can we move to the next question? 10th. It's very easy question. For verifying Ohm's law, we design an electrical circuit diagram in which we show the arrangement of different circuit components. We find that with respect to resistor, ammeter is connected in parallel and voltmeter is in series. This is the first option. Second option says ammeter is connected in series, voltmeter is in parallel. Ammeter and voltmeter are both connected in series and they are both connected in parallel. Which of the option is true? Which of the option is true? B. Trev is back. Trev is saying B is true. Others? which option is true? There is a circuit diagram. We have a resistor. The ammeter and voltmeter, with respect to the resistor, how will they be connected in that circuit? Voltmeter parallel, ammeter series. Amit is also saying B. Okay, both of you are correct. Ammeter is always connected in series with respect to resistor, and voltmeter is always connected in parallel. Okay, next question. Okay, before that question, go join our WhatsApp channel if you haven't already. We are there, the WhatsApp channel. You will get all the notifications for all the lives, for all the videos we are preparing for you guys, and we are coming with very fresh crash course for you guys for 10th class boards very soon. So I want you to go ahead and join the WhatsApp channel so that you don't miss any updates, and also like this video right now. What happened, Amit? Why are you sad? Like this video right now. We are done with electricity chapter and we are moving to the other chapter, which is magnetic effects of electric current. Okay, move on. Did you move on? Okay, next question is from the very first question from the chapter, magnetic effects of electric current. It's an assertion reason question. Let's read it carefully. Okay, read it very carefully. Assertion says two magnetic field lines around a current carrying straight wire do not intersect each other. It's correct. We know that magnetic field lines do not intersect each other. But the reason is saying the magnitude of the magnetic field produced at a given point, the magnitude of magnetic field produced at a given point increases as the current through the wire increases. Correct? What is the correct option? अच्छा नहीं लग रहा है. क्यों अच्छा नहीं लग रहा है? What happened? It's just 1 PM in the afternoon. अच्छा नहीं लग रहा है usually comes at 3 AM in the night. Okay, answer me this question. Anil is saying B. B is right. Anil is also saying B. Amit is also saying B. Correct. Both of these statements are true, but this reason is not the actual reason of assertion. We know magnetic field lines do not intersect each other, and we know magnetic field increases with increase in current. But this is not the correct reason for our assertion, right? So B is the correct answer. Next question. Read it carefully. Okay, free fire. If you are just here to spam, I can't stop you. And if you are a 10th class student and your boards are there, so I suggest you to hold your free fire for some time. Name the device used to magnetize a piece of magnetic material. A device used to magnetize a piece of magnetic material. Draw a label diagram to show the arrangement used for the magnetization of a cylinder made of soft iron. Can you answer this question? Anyone who wants to answer this question? What is the device that we use to magnetize a piece of magnetic material? Anyone? Solenoid. Who said solenoid? Solenoid. Amit is also saying solenoid. So all of you are spamming now. Okay, so it is correct. The device, now we know we have a solenoid. And we know when we pass the current through this solenoid, what happens is a magnetic field produces through it, via it, and this is the device which we can use to magnetize a magnetic material. And normally the device we use is, the material we use is soft iron core, that is used in NCERT, and the device that we use is solenoid. It is solenoid. Correct. Very good. Okay. Let's see the second part. Draw a label diagram to show the arrangement used for the magnetization of a cylinder made of soft iron. So simply this is the circuit. You just place a soft iron cylinder. Correct. This is a soft iron cylinder which we place inside a solenoid. So what we'll do is we'll take a soft iron cylinder and we wrap. What will we wrap? Insulated copper wire on that soft iron, and when we pass the current through it, the soft iron will get magnetized. Correct? Okay. Maybe you can just ignore them. What can we do? Okay. Everyone understood? This came in 2024. Understood? Can we move to the next question? Okay, 13th. Again, in this chapter, magnetic effects of electric current, you will be getting a lot of questions to draw magnetic field lines, draw the device, draw the direction of magnetic field or force. So be ready for it. Okay. Now 13th question says, draw the pattern of magnetic field lines of a current carrying solenoid and a bar magnet. Can you tell me what kind of magnetic field lines do these will have, or the direction of these magnetic field lines? Abhimanyu is saying, guess who's back? Guess who's back? Shady is back. Okay. Can you answer me this question? What will be the direction of, I'm not asking you to draw in the live chat, what will be the direction of magnetic field lines outside and inside both solenoid and bar magnet? Will they be different? Will they be same? And what will be their direction? I want the answer quickly. It's a very easy answer. Come on, guys. North to south, Anil is saying. Okay, this is very basic. Let's just do it. We have a solenoid. Okay. And then we have a bar magnet. This is a bar magnet. Correct? Now, negative side will be north and positive will be south. You remember these two? From negative, north, N. Okay, you can remember this. Now, inside solenoid, these will be the magnetic field lines. Correct? This will be the shape of magnetic field lines. What will be their direction? Outside north to south, outside north to south, inside south to north, inside south to north. Correct? Done. Same for bar magnet. The shape of magnetic field lines will be similar. Make sure that your magnetic field lines are closed, then don't leave them open. The outside it will be north to south, inside will be south to north. Correct? B part is list one distinguished feature between these two fields, the field of magnetic field of solenoid and the magnetic field of a bar magnet. What is the difference between these two fields? Can anyone tell me? What will be the difference in the fields of these two magnetic fields? Who's going to tell me first? What is this? it can change. What can change? Okay, well, this is technically right. I understand this, but your teacher will not give you marks if you just write it can change. It can change in solenoid, correct. So in solenoid, if I increase the current, if in solenoid, if I increase the current, the strength of magnetic field lines can change. If I reverse my battery, if I instead of this, if I place my battery like this, the polarity of magnetic field can change, correct. Now this will be north and this will be south, so direction of magnetic field lines will change. So polarity can change, magnitude can change, and it can also to some extent we can write, it can also help magnetize a magnetic material. On the other hand, for bar magnet, the strength can't change, the polarity can't change. So these are the distinguished features, correct. Okay, 14th question, big question, read it carefully, very simple. Read it carefully, very simple question. It's just easy peasy. Read it calmly, okay, calmly. What will be the answer? Numerical karao, ma'am, beta. I've done the numericals for electricity chapter. From this magnetic effects of electric current, numericals won't be there. It's a theoretical chapter. So you'll get questions like draw the magnetic field, what will be used, what will be the factors affecting the magnetic field. So you have to get your concepts strong for this particular chapter. Amit is saying C. Okay. Other? Everyone else? Trav is also saying C. Option C, correct. Abhimanyu is also saying C. So everyone is saying C. I'm so glad you guys took your time, read the question carefully, and then gave the answer. So the question is, for a current in a long straight solenoid, north and south poles are created at the two ends. Among the following statement, the incorrect, remember the incorrect statement is, first is the field lines inside the solenoids are in the form of straight lines. That is correct, which indicates that the magnetic field is same at all points. That is correct. Inside the solenoid, magnetic field is same at all points. So A is not the answer. B says the strong magnetic field produced inside the solenoid can be said to magnetize a piece of magnetic material like soft iron when placed inside the coil. This is also true. So for this question, this is not the answer. Then C, the pattern of magnetic field associated with the solenoid is different from the pattern of magnetic field around a bar magnet. We just saw in the previous question, both of them have same pattern of magnetic field. So this actually is not true, but we need to see the incorrect statement. So this is the correct answer. If we read D, the north and south poles exchange position when the direction of current through the solenoid is reversed. This is correct. Okay, next question. Parveen is also saying C. I don't know how to do numerical. There are multiple videos on my channel. If you even start the live from the starting, it will be there and on the channel in some time. You can get to see the numericals. I have covered all kinds of numericals: electrical energy, power, resistance, equivalent resistance, voltage, current, everything. Okay? Okay. Next question. Read it carefully. A magnetic field line is used to find the direction of what? Oh, this is very simple, but this is a CBSE board question. I don't remember which year, but this is a CBSE question. बोर्ड में आएगा इससे न्यूमेरिकल इन टेस्ला. Okay, the magnetic field, you need to find the, what do you say, numerical on magnetic field. Let me see the board exams, the paper I have gone through, there wasn't any previous year question on numerical where you need to find the value of magnetic field. D. Danish is saying C, and Zoya is also saying C. Everyone else is saying D. A magnetic field line is used to find the direction of, come on, it's the direction of magnetic field. It's the most simple question. South, north poles, we don't need to find. Compass needle, obviously no. A bar magnet, the direction of bar magnet, the direction of magnetic field lines around the bar magnet could be a correct answer. But we need to find the direction of magnetic field only. So if they say the magnetic field lines, direction of magnetic field lines around a bar magnet, then that will be correct. But here the direction we use to find is magnetic field. Okay, 16th question. An induced current is produced when a magnet is moved into a coil. There is a coil and we have a magnet, let's say a bar magnet, north. That is the most hideous diagram ever. Okay, so this magnet is, we are moving inside and outside, okay, moved into a coil, okay, just into, we are moving this magnet into the coil. The magnitude of induced current, the induced current which is there in this coil does not depend on the speed with which the magnet is moved, the number of turns of the coil, the resistivity of the wire of the coil, or the strength of the magnet, on which the magnitude does not depend. The magnitude of current will not change due to which. C. Doesn't depend on speed, Trev is saying. Okay, let's see. So we know that this magnet will technically produce a force, okay, technically give a force. It will produce a magnetic force, it will have a magnetic force around it, and when we take it near the magnet, that force will impact this magnet and hence it's changing its current. So we have two formulas, Q VB sin theta, correct, and the same is I L B sin theta. Can we just check from these two formulas, correct? What is the speed? So speed is there in the formula, so it will impact the force. The speed is there, so it will impact the force. The number of turns of coil, so the number of turns, we know that if we increase the number of turns, the magnet, the current will increase, okay, so that is also not the answer. First is also not the answer. The resistivity of the wire, can you see resistivity anywhere in this formula? No, right? So resistivity, on changing the resistivity of the wire, the current change will not be affected due to the motion of, the current will be changed due to the resistivity of the wire. It can change, but we have taken a wire. Now we are just moving the magnet and we are asked, will that movement will affect the our current in the circuit or not? And the strength of the magnet, of course we increase the strength of the magnet, the current will change. Okay, what did you ask? Please answer my question asked above. What question did you ask? Can you ask again once, please? Jasmine is saying, is it from class 10th? Yes, it is from class 10th. This particular formula they won't ask you in exam, but these are there for theory and you can use it to answer the these kind of questions. Okay, this will be asked. Yeah, so questions based on these formula will be asked from you. There was a question, maybe I have it, let's see, we'll use it again. Yeah, this is the one. Okay, answer this. This will be based on that formula only. You should know that formula to answer this question, and this is a multiple times repeated question. Okay, Rashi. Okay, Rashi. So this formula is important. You need to remember so that you can answer these kind of questions. Okay. The force experienced, we need to see the force. Okay. The force experienced by a current carrying conductor. There is a current carrying conductor which is placed in a magnetic field. We don't know the direction still. Now this is largest when the angle between the conductor and the magnetic field is. This conductor and the magnetic field, how this conductor should be placed in the magnetic field so that the force will be maximum. Okay, let me draw. This is my magnetic field, correct? First is 45 degrees. These are the four scenarios that are given. Okay. So first they said the conductor is lying at 45 degrees. Something like this. This will be 45 degrees. 60 degree. Something like this, a little more slanted. 60 degree. 90 degree. So this is 90 degree. The conductor is making 90 degree with the field. 60 degree, 45 degree and 180 degree. So this is opposite. So this is making 180 degree. In which case the force will be largest. 90 degree. Amit is saying C, Anil is saying C. Danish is also saying C. Abhimanyu is saying 90 degree. So all of you are correct. This is 90 degrees. But how did you answer this? What is the logic behind your thinking, or you just crammed it? What is the logic? How did you answer that due to 90 degrees the force will be largest? Can anyone answer this question? Why will the force be maximum at 90 degrees? It will be because of this formula we just saw, QVB sin theta or ILB sin theta. So basically we are finding force there and we are using sin theta. So the length of the wire, this length, or we can say the velocity, this length is making angle 60 degree with my magnetic field. So sin 60, correct? Sin 60 is what? It's root 3 by 2, I guess. Then sin 45 is 1 by root 2. Sin 45. Then sin 90 is 1 and sin 180 is 0. It is 0. So maximum is sin 90. That means force between magnetic field and the conductor, the force will be maximum when theta is 90 degree. Okay. Understood this question? Now you understand why you need these formulas? Let's move on to the next. Next question says, 18th question, it says, if the direction of current in a solenoid, when viewed from a particular end is anti-clockwise, then this end of solenoid will be north pole, south pole, east pole, west pole. Do you know the answer to this question? This is a good question. कितने क्वेश्चन और हैं मैम? This is 18th. We have 2 more questions. This is a 20 question series, 20 PYQs for your boards, for your pre-boards, and it's very, very important. These questions are A. Amit is saying A. Anyone else? Yes, yes, yes. I saw your answer. Amit is saying A. It will be a north pole. Trev is also saying north pole. Danish is also saying north pole. Everyone is saying north pole. Okay. So you guys are correct. This is a north pole. So in solenoid, when viewed from a particular end, so let's say from this end we are seeing that my field is anti-clockwise. Anti-clockwise. And we know for anti-clockwise that part will be, hello, I am new student. Hey, hi. What should I call you? Kushwaha. Bunty? Kushwaha? Will you come live more? Yes, in this week only I'll have 2 more lives where I'll be covering other 2 chapters of physics, which is light and human eye. Okay, North Pole, everyone is correct. So we know for clockwise, this is, do you guys also remember this like this? So this is going downwards. So in this it will be downwards, it will be clockwise. For South Pole it will be clockwise. For North, now this is anti-clockwise. So in this it will be anti-clockwise. So whenever they ask you that the field is anti-clockwise or it's a North Pole, you can answer it's a North Pole, or if the field is anti-clockwise, it's North Pole. If there's North Pole, the field will be anti-clockwise. Correct? Yes, yes, yes. Next, I'm going. Okay, what is the difference between a bar magnet and an electromagnet? I need you guys to answer this. Write it down. It will take you a little bit effort. I know you chat a lot. When you chat for hours, that time you can easily write. Huh? Hi, how are you? What are you doing? So you can write your answer here. You come live more, ma'am, and I saw today you are live for the first time and you teach us so good. Thank you, Rashi. Thank you so much. I will come live till your boards. We will handle you, we'll keep your hand with us till, we'll guide you till the boards. Vikas, okay. Vikas Kushwaha. Electricity. Okay, electricity, but still you need to write your answers with very carefully. Field lines are fixed for bar magnet. Okay. Ma'am, I am not, but I know. Sure, sir, in Vedantu. Okay. Bhumika Kushwaha. Okay, hi everyone who's new here. We are doing the series on our channel. The series, there are 2 series which are going on. Most repeated PYQs and most important questions, most expected questions. You can join our live. Also, one more thing, there was a live scheduled for SST today at 5 PM. Tanvi ma'am is not doing well. So instead of Tanvi ma'am, Murtuza sir will be coming live for maths. Okay, so you can also join that for 5 PM. And for physics, I'll have another live on Friday and Saturday where I'll be doing the chapters light and human eye. Okay, okay, there are answers. Let me read. The primary difference is that a bar magnet is a permanent magnet with a constant magnetic field, while an electromagnet is a temporary magnet whose magnetic field can be turned on off by control. Correct. Bar magnet is permanent. Okay, electromagnet can change the direction of current. Correct. Every one of you is correct. Flow of electric current through a coil of. Correct. Every one of you are super correct. Let's see these answers in detail. Okay, you can take the screenshot if you want. There are all these points. First is, of course, bar magnet is a permanent magnet. Then electromagnet is a temporary magnet. Then bar magnet does not require electricity to produce magnetism, whereas electromagnet requires electric current to produce magnetism. The magnetic strength is fixed and cannot be changed in a bar magnet, but in here, if we change the current, or if we change the number of coils, we can change the strength of magnetic field. Correct? Or the magnet, the electromagnet, we can change the strength of electromagnet if we increase the current through it. It cannot be switched on or off. Bar magnet will always attract or repel other magnets or iron fillings. But electromagnet, if we switch off the current, the electromagnet, it is a temporary magnet, so it will again come back to its normal state, okay, which is not magnetized. Okay, the other point is, made of hard magnetic materials like steel, bar magnets, and then electromagnets are mostly made of soft iron core with a current carrying coil. Okay, these are used in compass or fridge magnets or toys. These are electromagnets, can be used in bells or relays, cranes or motors. Okay, we had a electric motor before in 10th where we even applied this. Okay, just one more question left, guys, but it's a very good question. Very, very great question. Study this, read this carefully, and it's a CBSE question. Read it carefully. A constant current flows in a horizontal wire in the plane of the paper from east to west. This is a plane of paper and a constant current is flowing from east to west. Okay? As shown in the figure, the direction of magnetic field at a point will be north to south. They are asking at what point around it, at what point the direction of magnetic field will be north to south. B. Amit is saying B, directly below the wire. Okay. Tanish is also saying B. You guys are so intelligent. Or you have done these questions before. C. Abhimanyu is saying C. Either way, you guys are tremendous. Abhimanyu is saying C. Shivansh is saying ma'am SST. SST will be scheduled recently. There are multiple lives of SST that are on our channel. You can go watch those till then, and as soon as Tanvi ma'am is well, she'll come and have your live. Okay. B. Okay, let's see how will we calculate this. So my current is, this is how my wire is located, and the current is moving from east to west. So we'll use right hand thumb rule, and the thumb will point in the direction of current, which will be east to west. So it's something like this, and my magnetic field lines will go like this. Correct? That will go like this. Now it will be concentric circles, something like this. Outside, this is my wire, and let's say this is my magnetic field. So outside the wire, the current is going inwards. So let's say at this point, the current will be inwards. Sorry, the magnetic field lines will be inwards, and we depict it like a cross. Inside the wire, it's coming outward. At this point, the magnetic field lines are coming outwards. So it will be outwards at the point lower. Okay. Now imagine from these options, you need to imagine that you are having a plane, having a paper. So you need to see how the lines are going. This is north, this is south. Okay. This is east, west, north and south. I just rotated it like this. Okay. Now this is north, south, east and west. So at what point the field lines will go from north to south? If I hold this wire and it will go like this, so this is north, this is south, and the field lines will go like this. Correct? So the answer is directly below the wire. Correct? I can see why you said this, but you should imagine that it's a pane of paper, not the board. The paper is like this and wire is placed on that paper. So this is my wire and the current will go like this. So just below the wire, it will go from north to south. Correct? 19 sahi hai mere. Very good, very good. Tremendous job, everyone. Okay, everyone. Okay, these are all the questions that we have for you guys in this live. I hope you learned something new from this, and I hope you come back again for more such questions, because all of us teachers are working very hard getting questions from you guys so that you can score 95 plus in your 10th boards. Okay, so for this I want you to like this session first. Be sure to like this session first. I can see lots of people are there. Go like this session, like this video if you like the questions, if you like the content. How many of you scored correct marks? Tell me your score if you can. Okay, like this session, go join our WhatsApp channel. You will get all the notifications there, all the rescheduling if any, and subscribe the channel as well. Like the video, subscribe the channel. Okay. That's it for this live. There will be another live at 5 p.m. Make sure to join that. It will be of math. Sir will also be taking so many questions. Okay, bye.